as I was saying, this is the 2009 Form B free response. And the types of series questions that you see don't really, I mean, there's different types, but it's not like, even though it was 12 years ago, this question could have been on this year's test, similar types. So the first thing it's asking us is, it gives us this power series for x plus 1 to the n. It says find the interval of convergence for the power series. So I would say that the easiest way for us to go about this is to recognize that this is what type of series. Yeah, it's geometric. It's a geometric series. And so we know that in a geometric series, if our common ratio, right, if that R value is less than 1, then it converges. Right? And so all we need to do is go in and say it's a geometric series with R equal to x plus 1. And the geometric series will converge if the absolute value of x plus 1 is less than 1. And that ought to just give us x plus 1 is less than 1, greater than negative 1, or x is less than 0, greater than negative 2. So that's probably the easiest way to do it. Did most of you do it that way? Hopefully. And so if you did it this way as a geometric, yeah, the ratio, yeah, we'll do it with the ratio test. In fact, in the scoring guidelines, it shows both of these ways. And so we'll do the ratio test. So if you did it this way, identifying that it was geometric was worth a point. Having this absolute value inequality was a point. And then getting that actual interval was the third point. And so you could have also set it up as a ratio. And so you would have done the limit as n approaches infinity of the absolute value of x plus 1 to the n plus 1 over x plus 1 to the n. And that would have just given you the absolute value of x plus 1. And using the ratio test, we know that if that is less than 1, that's when it converges. Right? And so we would have then done the same thing and got that it at least converges on negative 2 to 0. But since we didn't recognize, if we did using the ratio test, that it was a geometric series, that means we also have to test those endpoints. And so you'd have to go in and say, all right, well, what if I plugged in negative 2 to my series? If I plugged in negative 2 to my series, which is just x plus 1 to the n, we just have negative 1 to the n, right? So what was our series starting at? Was it starting at n equals 0 or n equals 1? I don't remember what the beginning of it was, and now I can't see. It's n equals 0, right? Just to make sure I have the right thing written there. Yeah, and so then you would note that, well, this becomes negative 1 to the 0, which is 1, and then it'd be negative 1 to the first, which is minus 1, and then it'd be plus 1, and then it'd be minus 1, and plus 1, and so on. And this, the terms don't, just using the nth term test for divergence, we'd say this diverges. Right, this is the nth term test. And then we check the other endpoint. We'd do, right, this is at x equals negative 2. And then we'd say at x equals 0, we'd end up with n equals 0 to infinity of 1 to the n. And again, this is just the series of 1 plus 1 plus 1 plus 1 plus 1. And we would say this diverges also by the nth term test. And so your interval would still just be negative 2 to 0. So no problem using the ratio test to do it. No problem using the geometric series test to do it if you wanted to. Either way is good. Just make sure you do go in and check the endpoints if you use the ratio test. So officially, they said that would have been 1 point there. Having the radius of convergence was your second point, which would just be showing this. And then having the actual interval at the end would be your third point. But I don't believe if you didn't show the reasoning why it diverged at the endpoints, if you use the ratio test, I don't think they would give you that third point for having the interval. It doesn't specifically say that, but you really do need to show that. Does that part A make sense for everybody? Those are the two ways to do that. Probably two easiest ways. Cool. All right. Part B. What did Part B ask us? Part B says power series that they gave us is the Taylor series for some function f about x equals -1, and we want to find the sum of the series for f. And so in this one, we really should recognize, hopefully right off the bat, that it was geometric. And so we know that since it's geometric and the common ratio is x plus 1, our function f of x should just equal 1 over 1 minus r, right? And 1 being our first term, a over 1 minus r, 1 over 1 minus what was x plus 1, right, was our common ratio. And so the 1 minus the x gives you the negative x, and the 1 minus the 1 there, that gives you a negative, it gives you a 0 down there, so you just end up with -1 over x. And that's part B. And for part B, that was worth just 1 point for getting that. So recognizing that's geometric and putting that in. Everybody good with part B there? Okay, what did part C ask us? Part C said that g is the function that's defined by the integral from -1 to x of f, and we want to find the value of g of -1/2. Well, if we're looking for g of -1/2, and this is our function, all we need to do is integrate our value from part B. So if g of x equals the integral from -1 to x of f of t dt, as we should, we can put in -1 over t into that. So this is -1 to x. I'm writing f again. -1 over t dt. And what's the integral of -1 over t dt? Should just be what? Negative natural log, exactly. So this just becomes negative natural log absolute value of x, and we are looking for g of, what was it, -1/2, is that right? Yeah. And so we're just going to evaluate negative natural log absolute value of x from -1 to -1/2. So that should give us negative natural log of 1/2 minus negative natural log of 1 if you take the absolute value of both of those. Natural log of 1 is 0, so all that second step just cancels out, and you get negative natural log of 1/2, which we would normally rewrite out as negative natural log of 1 minus negative natural log of 2. First part goes away and just gives us natural log of 2. If you left it as negative natural log of 1/2, I think they'd give you the points for that too. I don't see why they wouldn't. But we just get natural log of 2. Good or no? And so I believe what they did is they gave you 1 point for having the correct antiderivative and 1 point for having the correct final value there. All right. And we had a part D, right? Part D gave us a new function, h, and h was defined by f of x squared minus 1. And so we needed to find the first three non-zero terms and the general term of this series for h about x equals 0, and then they wanted us to find the value of h of 1/2. And so if we are given f of x as 1 plus x plus 1 plus x plus 1 squared, etc., all we have to do is replace all of the x's in there with x squared minus 1s. So we should still have a 1 at the beginning, right? And that's for how many? The first three non-zero terms? So that second term, which was x plus 1, would become x squared minus 1 plus 1. So that would just become an x squared. And then the next term would become, which was, what was the next term? Next term was x plus 1 squared. And so if we plug in our x squared, we should get, or plug in our x squared minus 1, we should get x squared plus 1 minus 1 squared. So that would just be x to the 4th. And the next term would just be x to the 6th. It only asks for the first three non-zero terms. That's good enough. And then we can probably see that what is the pattern that we're getting here. This should be x to the 2n as our general term. And if we are looking for h of 1/2, how do we go about finding h of 1/2? H of 1/2 should be the same as f of what value? 1/2 squared minus 1, right? That's what h of x is. H of x is f of x squared minus 1. So that should be f of 1/4 minus 1, or f of negative 3/4. And if f of x equals negative 1 over x, then f of negative 3/4, flip it and take the reciprocal, ought to be 4/3. Good or no? Any questions on that? And so, yeah, points for this. 1 point for the first three general terms, 1 point, or for the first three non-zero terms, 1 point for the general term, and 1 point for the answer. How'd you guys do with that? Nah, just writing it as this x to the 2n is fine. When they talk about the general term, this is the general term, not the full series. So you don't need to write the sum from n equals 0 to infinity of x to the 2n, unless they specifically say write the series for the function. Then you need to write it in a series form. But if it just says the general term, then x to the 2n is acceptable. Any other questions on that one? Did you guys all get 9 out of 9 on that? Yeah, I would agree. This one was probably, somebody was saying in the chat, this one was easier than the last one we did. Probably true. I would say that was on the easier end of series questions that you might see on the AP test. All right. How about this one? You guys all had a chance to look at this one, right? Oh. Perfect. Okay, so starting off with, well, we can do part A at the bottom of this page here. Starting off with part A should have been exceptionally easy, right? Because you should know what the Taylor series for cosine x is. I told you guys to memorize the one for cosine x. And all they're asking you to do is to write out the first three non-zero terms and the general term. So what's the, to start with, for cosine. So what's the first three non-zero terms for cosine x? Cosine x should be 1 minus x squared over 2 plus x to the fourth over 24 or over 4 factorial. And our general term should be what? Negative 1 to the n x to the 2n over the quantity 2n factorial. So I should write this is for part A. All right, so the first part of part A should have been exceptionally easy. That was just having all of that was worth 1 point. The second part of it asked you to write out the first three non-zero terms and the general term for f about x equals 0. And so how should that start off? What should f of x look like? Nobody? Nobody's got anything there? Well, what is cosine? It's cosine of x minus 1 over x squared, right? So what is what does cosine of x minus 1 look like? Cosine of x minus 1 looks like this first, or at least for the first term, we're subtracting off the 1, right? And then that term goes away, right? So we subtract the 1 off from the whole thing, so that term is gone, and now we're dividing every other term by x squared, right? So this first term goes away. We're dividing everything else by x squared. So if I divide x squared over 2 by x squared, that's going to give me negative 1/2. And if I divide this next term by x squared, what's that going to give me? That should give me x squared, positive x squared, over 4 factorial. And the next term, what should the next term be? Should become a minus, and it was an x to the 6th, right? So it should become an x to the 4th over 6 factorial. And what does our general term going to look like? It should still be alternating, so it still should have a -1 in here, but since we're starting with a negative term, we're going to have to change that to an n+1. And then we still got x to the 2n in our numerator. That looks terrible. And then in the denominator, what do our factorials now become? They're no longer 2n factorial. They're now 2n plus 2 factorial. Good or no? That makes sense? You were all very silent when I asked about that one. Oh, no, you weren't. It just wasn't telling me that people were saying things in the chat. Huh. Sorry, that's so let me go back through and read what you were all saying in the chat that I didn't ever see. Normally it like lights up when you're saying things in the chat. No, you don't need to leave it as, you can leave it as 4 factorial or you can write it as 24. It doesn't really matter. And then, yes, -1/2 is the first term. That is correct, Nick. What do you mean you don't get the denominator part? What part of the denominator? I mean, how we got 2n plus 2 factorial, or you're good? Okay. All right. Yeah, sorry, I don't know. Normally it lights up when you guys are saying things in the chat, and it didn't that time, so I apologize for thinking you all weren't saying anything. I mean, I don't apologize that much, but okay. So let's see, what were the points for that? They must have given you, since they asked you to find the first 3 general terms, so 1 point for the general terms there and 1 point for, for the first 3 non-zero and 1 point for the actual general term. Everybody good there? With part A? Open up the chat and make sure everyone feels good. Everyone feels good about that. Makes sense to everybody? So Shayla, it's the 2n plus 2 factorial. If we just look at each, we just kind of got to come up with that. We'll notice that we had 2n factorial for cosine, but since we divided by the x squared, each of these terms dropped down by a power of 2, but it didn't change the factorial. So like my x squared over this one, this was x squared over 2 factorial, even though we just wrote 2. 2 factorial is 2. That just dropped down to -1 over 2 factorial. And then this one dropped down to 4 factorial, right, from the 4th to the 2nd, but still with 4 factorial. And so since this is now the 0th term at the beginning here, we need to make sure that we add 2 to this original factorial, so 2n plus 2. And that should carry over to each of the rest of these. So this one, when n is 1, it's 2 times 1, which is 2, plus your 2, so 4 factorial. When n is 2, it's 2 times 2 plus 2. And so, does that make sense? Cool. All right. So what was part B asking? Part B was asking us to use the series for f about x equals 0 that we found to determine if f has a relative max, relative min, or neither at x equals 0. So what do we have to do with that? We need to find the a derivative, right? To start with. That's how we determine where things could have a max or a min. So we want to figure out what does f prime equals 0. And when does f prime equal 0? Well, it looks like f prime should equal 0 if x is 0, right? That's what we're looking at. So we're interested in is f prime of 0 a max or a min or either. So f prime of 0 but how are we going to determine if the function is increasing or decreasing there? We'll need to use what will we need to use? Okay, we could use a sign chart. That's going to be a little more difficult, though, I think. I think it'd be easier if we used a second derivative test. So if our first derivative is 0, at 0, we can look at the second derivative of our function at 0 and figure out what our second derivative is. So let's look at what f double prime of 0 is. And if f double prime of 0 is positive, we should have a min. And if f double prime is negative, we should have a max. So how do we figure that out? If we go back over here, f double prime what should f double prime at 0 be? Okay, so we need to find so what we need to do is we need to find f double prime. So if we're looking at f double prime, looking at this first term, -1/2 is going to go away. But this one, right, as we take the derivative of this, we should end up with what? 2x, well, so it should be the derivative of 2x over 4 factorial, which should be 2 over 4 factorial, which should be 112. Minus, we got all these other terms, but if I take all these other ones, these ones are all going to become 0, right? So it's really just this term that I'm looking at that I should be concerned about. This one becomes 0, and these ones at x equals 0 becomes 0. And so 1/12 is greater than 0, which tells us that we have a minimum. Does that make sense or no? Everybody good with that or no? Okay. Cool. And let's see, what are the points there? So yeah, 1 point for finding the derivative properly at 1 point, and 1 point for saying it was a minimum with the reason that it was greater than 0. All right, part C. What did part C ask us about? It asked us to write the 5th degree Taylor polynomial for g, which they gave us g at the beginning, 1 plus the integral from 0 to x of f. So fifth degree Taylor polynomial for that. So how do we write a fifth degree Taylor polynomial? First, we have to evaluate our original function, g at 0. So what is, let's go back to our page, what's g of 0? If you plug g of 0 in, that should be 1 plus the integral from 0 to 0 of f. What's the integral from 0 to 0 of f? Integral from 0 to 0 of f should be, so Delphine, I'm finding g of 0 because we're supposed to be writing a Taylor polynomial, fifth degree Taylor polynomial for g. And so in order to write out those polynomials, we need to get the, well, I guess we don't need to. I was going to write out it term by term, but we can just, I guess, integrate, add the 1 and integrate term by term. That's fine. We don't have to do that. You're right, probably doing it the other way is easier. So what should we get as our first term? Our first term should just be 1. And then our second term, if we integrate our first term from before, should be what? It should be minus x over our 2 factorial, or over 2. And our next term should be what? Should just be x cubed over 3 times 4 factorial. And if we look at the next term, our next term should be x to the 5th over 5 times 6 factorial. And so on. And did it ask for a general term? I don't think, no, it was just, no, we just wanted the fifth degree Taylor polynomial. So that would be our fifth degree Taylor polynomial. And strangely enough, what they gave you points for here, if you had 2 correct terms, you got a point, and if you had the rest of the terms correct, they gave you another point. So that's that. You know, the 1 at the beginning comes from the integral, the 1 plus the integral, and then we just integrate our terms until we have a fifth degree polynomial. Good or no? Any questions on part C? Just integrating term by term after you get that 1 in there. All right, part D. So part D was saying now the Taylor series for question. Yes, Nick, all we did was integrate the terms of the series for F. Yep. Because remember, it's a Taylor polynomial, it's going about x equals 0. And so we already had f about x equals 0 written up to 4th degree. We could have had it for as many degrees as we wanted to. So to get a 5th degree for this one, we just added the 1 at the beginning and then integrated each term by term. Okay, so for part D, they're now talking about the series for g at x equals 0 that we're evaluating at x equals 1. And they're saying that it's an alternating series with individual terms that decrease in absolute value to 0. And we want to use the third degree Taylor polynomial for g to estimate the value of g of 1. Right? So the third degree Taylor polynomial for g would just be 1 minus x squared over 2 factorial plus the x cubed over 3 times 4 factorial. And so for part D, we already had a page for D, didn't we? We just want to plug in those terms. So plugging in 1 for each of those, we'll still have a 1 minus a half. And then plus, what is that one? 3 times, what is that, 24, so 72nd. And so what would that estimate come out to be? That's a half plus 1 over 72, so that'd be 37 over 72. So that's the first part of it. Just estimating it at x equals 1. And then it also says, explain why this estimate differs from the actual value by less than 1 over 6 factorial. And so because of all the information that they gave us here, that it's an alternating series and the individual terms decrease to 0, that meets all 3 of the criteria to use the alternating series error bound. And so that means that for any alternating series, the error is always less than the absolute value of the next term. And so that should tell us that our error should be less than 1 over 5 times 6 factorial, which is most definitely less than 1 over 6 factorial by the alternating series error bound. Does that make sense? Any questions on that one? Yeah, so they stated in here that it's an alternating series. They said that the terms decrease in absolute value and that they decrease to 0. So there's 3 criteria to use the alternating series error bound. 1, has to be alternating. 2, terms have to be decreasing in absolute value. And 3, the limit as n approaches infinity of the nth term has to be 0. So in their statement here, they've used all 3 of these, or they've met all 3 of those criteria, which tells us you can use the alternating series error bound to say that the error by truncating it after 3 terms is always going to be less than the 4th term. So we truncated using 3 terms to get 37 over 72, which tells us that the error must be less than the 4th term at x equals 1. And the 4th term at x equals 1 is 1 over 5 times 6 factorial. And that is definitely less than 1 over 6 factorial, which is what they wanted us to state, that the error is less than. Does that make sense? Cool. Anybody else have any questions on any of the parts of that one? This one's a little more difficult than the other one, but still, I think pretty doable. I don't think it's too terrible. Everyone good? All right. So I think we've got time for you guys to work through one problem, and then hopefully we'll have time to go through it. If not, we'll go through it next time, or if we don't finish going through it today, we'll go through it next time. But let's take about 15 minutes there and see if you guys can do this one. So I will give you 15 minutes. I'm going to set the timer for 15, and you guys can work this. Ready? Go. All right, so for part A, finding the interval of convergence, we just set up a ratio using the ratio test. So since those are not all positive terms, take the absolute value, and when we take the absolute value, that -1 to the end, -1 to the n will become insignificant, right? So we're going to have 2x to the n plus 1 over n plus 1 minus 1, which should just be n. And then we'll divide that by the original series, so we'll multiply by the reciprocal of it. So that'll be an n minus 1 in the numerator and a 2x to the n in the denominator. Everybody good there? Giving us a limit as n approaches infinity of absolute value of 2x times the n minus 1 over the n, which is just the absolute value of 2x. Good to start with. And so then that's part A. So then we would say the absolute value of 2x is less than 1, which would give us a radius of convergence of 1/2, and tell us that it converges at least for x is less than 1/2, greater than -1/2. And we would need to then check the endpoints, right? And so if you got up to here, 1 for setting up the ratio, 1 for getting the right radius of convergence, and 1 for evaluating the limit correctly, I got 3 out of the 5 points that part A was worth. If you didn't check the endpoints, then you couldn't get more than that. So checking your endpoints. So if we look at -1/2, at -1/2, this should then become what, -1 to the n, and then another -1 to the n. And in our denominator, it should just still be n minus 1. And what does that become? That's the sum from n equals 2 to infinity. That's just 1 over n minus 1. And what do we know about that? This is the harmonic series. I got a -1 here, which puts it starting at 1. That's 1 minus 1/2 minus a third, or 1 plus 1/2 plus a third plus a fourth plus a fifth. And we know that the harmonic series diverges by the p series test. So at -1/2, it diverges. And then at x equals positive 1/2, we end up with -1 to the n times 1 to the n over n minus 1. And this is the alternating harmonic series. And we know that that converges by the alternating series test. And so our final interval should have been -1/2 to 1/2 inclusive. And so you got 1 more point for testing them both, or making an attempt to look at the endpoints, and 1 point for getting the actual value of the endpoints. The nth term test would not work, Nick. The nth term test only specifically tells you if something diverges, and it only tells you that it diverges if the terms don't approach 0, and both of these, the terms do approach 0. Right? If you look at 1 over n minus 1, as n goes towards infinity, the terms approach 0. So that tells you that it could converge or could diverge, and the same with the other one. Darius, do you need to specify? No, I mean, you wouldn't have to say that it's the harmonic series or the alternating harmonic series necessarily. I mean, you could just say it's the harmonic series which diverges, and then you don't even really have to write the p-series test. It's just a known fact that alternating harmonic series converges and harmonic series does not. So, everyone good with part A? All right, now for part B, sounds a little weird, but it's not as bad as it seems. They want us to show that y equals f of x, so that this series is a solution to this differential equation, that xy prime minus y equals this, and that it has the same radius of convergence. So all we need to do is figure out what xy prime minus y is. So we'll start by figuring out what y prime is. So let's start by writing out the series for y. So what does the series for y look like? First term of that should be at n equals 2, right? It should be 4x squared. And next term should be what is the next term for that to be? At n equals 3. Now that I don't have the series in front of me. Full minus 4x cubed, it looks like. And what's the next one? I think it's 16 thirds, right? X to the 4th. What's the general term of that? Right, it's just our negative 1 to the n, 2x to the n over n minus 1. Okay, so then what's y prime? Y prime ought to be 8x minus 12x squared plus 64 thirds x cubed and so on, right? And what's the general term of that look like? Should be negative 1 to the n. And what's the derivative of our 2x to the n? That should be n times 2x to the n minus 1 times the derivative of 2x. So that should be 2n times 2x to the n minus 1. And if you use the chain rule to take the derivative of that, all over n minus 1. Okay, and what do we need to multiply that by? We need to multiply that by if we look back here, x, right? We gotta multiply by x and then subtract y. So what does x y prime equal? Well, that should be 8x squared minus 12x cubed plus 64x to the 4th over 3, and so on. And if I put in an extra x in here and multiply all this by x, what does that give us? I can multiply the 2 in here to make it 2 to the n. I can multiply the x in to make it x to the n. So that would just be n, and then it would be 2x to the n over n minus 1. Everybody good with that being xy prime? And if I multiply everything by x, I'm throwing an x into here, which makes the x go to the power of n, and then the extra 2 makes the 2 go to the power of n. So I just wrote it as 2x to the n. Okay. And if we're going to subtract y from this, well, 8x squared minus 4x squared is going to be 4x squared. And negative 12x cubed minus negative 4x cubed is going to be negative 8x cubed. And the 64x to the 4th, or 64 thirds x to the 4th minus the 16 x to the 4th over 3 should give us, what does that come out to be? 48x to the 4th over 3, which I think is 16 x to the 4th. And then what? What do we make this series then look like? We're subtracting what are we subtracting off of it? We're subtracting off of it this, right? So negative 1 to the n times n times 2x to the n over n minus 1. What does that become if I take this and subtract this? G becomes G. There's no G in here, Nick. I mean, I've still got, what do I have here? I have an alternating series, right? And what's happening to each of these? Starting at n equals, these all start at n equals 2, right? So what is this? This is 2x to the power of n, isn't it, each time? But it's alternating. So -1 to the n, 2x to the n. That'll give me 4x squared for n equals 2. For n equals 3, it'll give me minus 8x cubed, and then plus 16x to the 4th, and so on. So xy prime minus y is the series of -1 to the n times 2x to the n. And what do you know about this series? It is, what kind of series? This is a geometric series, okay, with a common ratio equal to 2x. And so if the absolute value of 2x is less than 1, it should converge. And that should give us x is less than a half greater than -1/2. And so therefore it's got the same radius of convergence, right? It just asked about the radius of convergence, not necessarily the exact same interval of convergence, but it asked for the same radius of convergence. From radius of convergence from part A was a half. Good or no? Any questions on that one? Less confusing now, those of you that said you were having trouble with B?
So basically this should equal to 4x squared over 1 plus 2x,
right?
Because the right side said 4x squared over 1 plus 2x.
Yeah, that is correct, yes. Yep. Yeah, I mean, oh, well, yeah, this equals 4x squared over 1 plus 2x. Yeah, I mean, this xy prime minus y equals 4x squared over 1 plus 2. I guess we should have shown that. I didn't really show that at the end there. I forgot to show that. So this is first term A over 1 minus our common ratio. And our common ratio is -2x. So yeah, 4x squared over 1 plus 2x. So we should show that. Good or no? And that was worth 4 points. I think they gave you a point for having each of these series along the way, y prime minus y, and then another point for getting 4x squared over 1 plus 2x with the radius of convergence of 1/2. Any other questions on that? I know we're now like 5 minutes over, so. And yeah, Nick, that answers your question, hopefully. What Darius was saying. Yeah, Shayla, I'll have the ratio. Oh, the ratio. Oh, I didn't do the ratio test answer key yet. Yeah, I'll have the ratio test one up today also. I thought I put that one up already. But yeah, I'll put that up also. Anything that's missing, I'll have up today. All right, that is it.